see here. Just gotta get to my folder real quick.
Sure, yeah. No worry.
Okay, I'll share my screen. All right, is everyone able to see this?
Yep.
Okay, so for my Roman numeral solution, I decided to, well, in one implementation, I decided to go with a list of list pairs. And basically, I end up using a filter to filter out any lists that are greater than the current number. So then if the, I gotta remind myself on why I made these decisions that I did, but basically it filters these out and it'll return a blank if this then the remaining number is equal to 0. So I added this 0 down here so that ends up being our base case for the recursion. And otherwise we return the numerals letter, and then we call Roman numeral again with what's remaining from our number. So we subtract the first index of one of these sublists. So this number gets subtracted, the letter gets added onto our string, and we call Roman numeral again with what's remaining. So then at the end, we end up with our full string. I can run these tests here just to double check that it actually works. So all of our tests pass. This section here is all the Roman numeral stuff. So that's pretty much my solution.
Cool. Nice. Yeah, that's a very innovative way of solving that, I think.
Thanks.
Do you want to leave it up for a sec so we can look at it?
Oh yeah, sure. Bring it back up.
So, and on line 27, you're going to get a list of, or basically all of these pairs, all of these, array pairs that are smaller. So if the number is 101, you'll get C, XC, L, and so on, all the way down.
Yes.
Okay.
Yep. So we filter all of these out so that we know that index 0 is the one that we want. And so we don't have to do any more searching through. We can just grab whatever's at index 0.
Okay. Does anyone have any comments or questions?
Could we actually talk through line 27? I'm not really super comfortable with the filter method yet, and the lambda still is new. So I'd love to go over just what's happening on line 27.
Okay, yeah, we can do that. So basically, the filter will apply any function to every element in an iterable that you give it. So for every one of these pairs in numerals, it's going to apply this anonymous function. And lambda x, x is just the parameter that's being passed into the function. So it's passing one of these into the function. And then we're checking that index 1 from that parameter is less than or equal to our number. So for every one of these, this logic gets applied. And if it's true, then the filter will include it. And then we just convert that filter into a list.
So the filter is creating the list. I got it. That's awesome. Thank you.
Yep.
Yeah, so we still haven't officially talked about lambdas or list comprehension, so that we've seen them lots and lots of times. So sooner or later, this week, in fact, I will explicitly talk about those things. All right. Well, thank you very much, Greg.
Yeah, thank you.
Okay. So now I'm going to show you my solution. Well, I was going to show you and maybe kind of like work through. We'll see if we can work through something. So I'm going to start with just my non-recursive solution. I'm going to paste that in here. Let's do. So starting with a dictionary, and then while the number is greater than 0, so whatever number we input, in this case, 102 or 5 or whatever, and then I'm just going to look over every element in this dictionary, all of these keys, which are numbers or integers, and I'm going to check if this number is greater than or equal to Arabic. So in this case, 102, this would be false, 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 false. I would stop at 100 because 102 is greater than or equal to 100. And then what I would do is append whatever value is here, in this case a C, to this result. And then I subtract this value from num. So if this were 102, I would subtract 100 and I would get 2. I would break out of this for loop so I don't keep going down. And then the while loop would start again and it would check. And in this case, num would be 2. So I would have another round of the while loop. And then I would go through again, this for loop would start, which is going to go through every element here. And we'll do that same check. In this case, it'll stop here, subtract 1. This will become CI up here, and so on. So this is just one way of doing it. There are, a lot of different ways of doing it. So I'm going to try to make this, I'm going to try to replace this while loop with recursion. So that'll be the first step. Does anyone have any ideas how we might go about doing that? So if I want to have a recursive method or function, what are the first 2 things I need to figure out?
You need your base case and your recursive case.
Okay. So let's get a base case going. Not sure why I used snake case there, but base case and
for the base case, you can use if num is less than or equal to 0, return the result.
Okay. And see, I've got this problem where I copied and pasted from, so my tabs are all off. Let me fix that. All right, sorry about that. So the base case is going to, my comments are still off. The base case is going to be, sorry about that. So if num, like, if num equals 0, maybe,
Yeah.
then we'll do something. We'll pass for now. And then in the recursive case, we'll get rid of the while loop. So the recursive case is going to, we're still going to need to go through this array, at least for now, or this dictionary one at a time.
You'll want to return in the recursive case instead of break.
Okay. So instead of break, we'll have a return. And at some point, we're going to have to call the function again, right?
Right there, yeah.
Okay. Do Roman, and then, well, since we have this one parameter here, num, we're probably going to have to pass in num again, at least. And we have a couple options for how we handle passing information to the next call, or, you know, how we handle the kind of information sharing we need to do. So one option is we could add another parameter, which would be ultimately what we want to return as the result, right? So this result is going to be a value that kind of accumulates for every function call. So we're going to need to worry about result, because if we don't do anything right now, result will, at the end of any given call, it's just going to be one letter or nothing. So we're going to have to do something with result.
Has result equals blank or in the parameters of the function.
Okay, so you could do that. We could pass it in here. We'll do it this way for now. So result, we have a result, and then we're changing the result. We're changing num, and then we're gonna call it with num and result. Let me move this up. All right, let's see if that works. Okay, we get none. So our base case, if num equals 0, we're passing. So this is, we still need to figure this out.
Return result.
Okay. So that looks like it works. We could try with some other things. I didn't really write tests here, but just as a quick eyeball, that looks roughly 1,000. 1,029. Yeah, that looks right. Okay. Okay, so so this is definitely one way of doing it. So we're adding a default parameter, and then we're passing the accumulated result into every function call. Is there another way we could do this? let's say we don't want to change the function signature at all. So ultimately what we're doing is the way we have it right here, we're basically going to accumulate a letter, or in this case like a couple letters, but let's just say a letter for every function call, right? So we're just adding one letter every single time. So we can express that a little differently by doing something like so whatever this result is, and we're gonna have to figure out what this is going to be. But so we're going to add the first function call, in this case 102. The first function call, it's going to return C. And then we're going to add C to whatever the function call is with 2, whatever's left over. And that's going to give us I, and then we'll have one more. So we're going to add, it's basically going to chain this together. So we have to change a couple of things. One is that we're not really going to remember anything from previous invocations here. So we'll need to set the result here. And then let's think about what happens in our base case now. So we call the function with 100, right? We hit here, so result equals basically 100. So we subtract 100 from num. So now num is 2, and result is C. So we have C plus 2 Roman, calling it with 2. So we go through again. In this case, result is going to be I. And then we have 2 minus 1. So for this particular invocation, it's going to be I plus 2 Roman with 1. And the previous invocation, which is in the stack somewhere, is going to be C plus whatever this is. So C plus whatever this is, this will evaluate to I plus whatever this is, and then this will again evaluate to I. So at the very end, all these things are going to get put together, and we'll get CII. Question is, on that last function invocation, what do we do with our base case? So at this point, let's say this is the last call, and num is now 0, and this is I. So we're calling 2 Roman with 0. So now this base case hits.
Well, if the base case is returning result and result is it's still going to be I, because the base case hasn't changed it to be anything else. Is that right?
Well, so if we think about the final function call, the final invocation, so result is going to be I, right? Because it's CII. So this will be the second I. So result will be I. We're going to add whatever the return value of the call to this function is. So we're going to get C plus I plus whatever this returns.
So do we then want it to return an empty string as result, and then when it goes back down, it'll put the I on, and then the I, and then the C?
Yeah, I think probably that's the best way to do it. So if we try doing something like, let's see what happens. So we get an error. So it looks like we made it through a few invocations. So we're probably down to the base case here, right? And then I get a type error, can only concatenate string, not none typed string. So I have a string CII, and then this returns none, and it's trying to do what's CII plus none, and it can't do that. So if we do an empty string, then we preserve the way we were doing it. Okay, but we're still, so this is a recursive solution. It uses recursion, but we are still using a loop here. So we could, fix that potentially. This could be a little bit more confusing. So, and this is more just like a bonus. So I'm going to say that this for loop, so we need to replace the for loop. And what the for loop is doing is just checking all of these against whatever value is passed in. So that's ultimately the basic functionality that we need. So one option is to, instead of grabbing this Arabic value, which is getting reassigned at every iteration, which is bad functional programming. So you don't want to reassign. You want to reassign things to variables. So instead of getting this value, one at a time, we will just call a function that will happen to be recursive that will get us that Arabic value, and then we can just directly access it in the dictionary. So I'm basically going to try to replace these two lines, but really it's the for loop that needs to get replaced. So let's try writing a function that will do that. So since we're getting the Arabic, we'll call this get Arabic numeral. And this is going to take the number. We're going to do this check, so it'll take in a number. And for now, so the goal of this function is to take in whatever the number is, and then to return something that will be a key in this dictionary. So you can grab it directly. So again, there are a few different ways to do this, but I'm just going to create an array of and I'll do 1000, 900, 500, 400, 100, 50, 40, 9, 5, 4, 1. All right, so I have these Arabic numbers, a list of Arabic numbers, and I'm going to do the same thing I was doing before. So I'm going to check. So if num is greater than or equal to so again, I could use a for loop here, right, to iterate over this and check, but then I'd still be kind of just kicking the can down the road, right? So if I want to get rid of for loops, I'm gonna have to do something else. So what I'm going to do is I'm going to check if the 0th, so I'm going to start from the highest value. I'm going to check if the number is greater than or equal to whatever the 0th index. And if it is, then I'm going to return that value. So return. And if it isn't, I'm gonna have to return this. So if the first time, I'm gonna check all these, I'm gonna get Arabic nums at 0. So I'll be right here. And if that's not it, if my number is like, 32 or something, then I'm gonna get rid of 1,000 and I'll have to go back through, but I'm gonna start at 900 this time. So again, there's a couple ways to do this, but I would, just my own personal how I like to do things. So I'm gonna add a default parameter. And I'm gonna do a check. I'll just I could do this in one line, but I'll do it like this. Actually, I'm just going to leave that. Okay, so I don't need to do that else. Okay, so now if I get a hit, so if I'm looking for 420, then when I get to 400, I'm going to return whatever. I'm going to return this number. And if I need to keep going, then I'm going to return get Arabic, and I'm going to return Arabic nums starting at everything past the first index. So I can use this convenient Python syntax. Right, so if I...
Don't you need to return num too?
Yes, well, yes, yeah, thank you. So let's just test this out real quick. Okay, so 10. So again, I'm not writing tests, I apologize, but so this function is working, and this will allow us to directly get the key that we're looking for here. So now I'm going to get rid of all this. And then I'm going to say Arabic is get Arabic, and I'm going to pass in num. So I get a num, I go through, let's say num is 102. Is num 0? No. So Arabic is get num 102. So this function is going to get called, it's going to return 100. So then I grab, the result will be conversion dictionary at 100, which will be C. And I'll subtract 100 from Arabic. And then I will concatenate result and just repeat the process all over again. Let's run this. We still get the same result. Okay, does anyone have any questions about that? In terms of satisfying the assignment, the first part is fine.
Chad, if you were using this with other files or other modules, would you want to wrap all of this in a class to keep those two functions together?
Yeah, I mean, it would depend, but I think as a default, yeah, probably. It would depend on kind of how you're using it and other things. Okay, so that's again just one solution for Romans. Get rid of that. So today, so I want to talk more about recursion and a little bit more, kind of go, I guess, another layer deeper. One sec, sorry. Okay, so the way we're using recursion, the way we have been using recursion is basically a replacement for a loop, right? So it's kind of like there's one small change, and then it's essentially a recursive version of a loop, and that's fine, and that's recursion. But there's kind of another, I would say, another flavor of recursion, which is closer to what real recursion is, the kind of problem that recursion is meant to solve, or that it solves more elegantly, and that's something called divide and conquer. So we'll see in the challenges. We'll see in the challenges there's a binary search, and binary search, I'll just describe it real quickly. So the way binary search works is, so we did linear search in the very beginning, which is I'm looking for John Smith's name in the phone book. So I start with, Albert Algernon or whatever, and I start there and I go down and I check every single person in the name until I get to John Smith way in the back. And that's fine. I mean, you can be sure that you're going to find what you're looking for. You're not going to miss anything. But you have to check every single one. So if I have a million entries, you're gonna have to do a million checks potentially in the worst case scenario. And if you have 10 million entries, you have to do 10 million checks potentially. Either the person could be the very last, or maybe the person's not in there. You have to look at every single one in order to determine that. So that's not ideal, especially once your numbers start getting larger. So something else you can do is we can use a strategy called divide and conquer. This assumes, like a phone book, that you have sorted data or sorted members. And if your data is sorted, then what you can do is you have your array, let's say an array or your phone book or whatever, and you just look in the middle. So the first place you look is the middle. And then you say, is what I'm looking for higher or lower? Or did I happen to get it? If it's higher, then you can throw away the first half of the phone book or the array or whatever you're doing, right? So every iteration will reduce your work by half. So if you have a million items in your array, the first search will get rid of 500,000, and the second search will get rid of 250,000, right? So instead of, so if I don't know what the math is off the top of my head, but if I have a million items in my array, I'm only gonna have to do like, no more than a dozen or so searches until I find what I'm looking for. So, and if I up that from 1 million to 10 million, then I just add like a couple more potential searches, right? So if I were doing linear search and I added 10 million more entries, I have to do potentially 10 million more operations. So divide and conquer is a very useful strategy when you can use it. And how it relates to recursion is that in order to come up with a solution that works with this, divide and conquer approach, you have to have a problem that repeats. You have to break it down into a small problem that repeats. So it's like a big problem composed of lots of small problems, and you can keep breaking it down, and it turns out it's the same problem, just repeating at different levels. So I'd like to go over one potential example. Actually, let me do something else real quick. All right, so I think we've figured out how to sum an array of numbers like 5 different ways. So I'll show you another way. So let's do it. Let's solve this problem recursively. So we have an array, and we need to write a recursive algorithm, recursive function. So how would we approach this? I want to take this array of numbers, and I want to get the value of all of them total together. So I'll repeat myself. What is the first thing we always have to do when we have a recursive solution?
Base case, recursive case.
Thank you very much. So it's always easy to get started when you have a recursive. You can always let's do. Oops. All right, we're halfway there. So we have a base case and a recursive case. So one way of thinking about this problem is to say, so what we want to do is we want to add 1 to the result of adding all the rest of these together. Right? So we don't know what that is, but that's what we want to do. We want to add 1 to whatever the result of this is. And in order to get the result of whatever this is, we have to add 2 to whatever the result of adding all this is. And in order to find out what the result of adding all this is, we have to add 3 to the result of adding all of what this is. I think I'm lost in my own words now, but so on the one hand, it's a big problem that gets composed into lots of smaller problems. And let's say I finally get here and I say, well, this is the result of adding whatever this is and whatever. Oh, wait a minute. I think I could actually perform this calculation, right? You can actually add 7 and 8. So looks like that's a base case. We can actually get a value, and then we know what this is. So now we can figure out what this is, right? Because 6 plus whatever this is, now we know whatever this is. We can add this, and then the dominoes fall, and we can go all the way back.
Jan, if you were to use pseudocode, how would you do pseudocode before we got started on this?
Yeah, so that is a great question. So yes. So I was kind of talking through it, but I didn't write. So let's think about how we could kind of pseudocode this out. So the problem, if we want to take a divide and conquer approach to this, we want to find a problem whose subproblems is just more of the same problem. that's not it's probably not very clear, but we want to find the one problem that solves all of these other problems. So all the problems are made from just example, you know.
So you said the goal is to add everything in that array, is that correct?
Yeah,
So would we need a loop to retrieve everything in there?
well, we're trying to do this without using a loop.
Oh, without using a loop, okay.
Yeah. So we're basically using recursion as an alternative to
Okay.
looping in this case. Yeah.
Mhm.
So the first thing we want to do is we're going to add 1 plus, I'm just going to say everything else. Right?
I guess that's where I'm glad we're doing the pseudocode. So is it 1 plus 2 plus 3 plus 4? Or are we trying to get the sum of all 1 through 8? I mean,
Ultimately, we want the sum of all of these. So I don't know what this is off the top of my head. Like,
Is there a sum function in Python?
Yeah. There's definitely.
Is there a sum
yeah.
function?
Yes.
Where we put sum in front of there or
Sure.
in front of that list?
Yeah, there's definitely an easier way to do this for sure. But I'm trying to torture you guys by making you solve it recursively. So there are lots of ways. So I think on Friday I showed you like 3 or 4 different possible ways to solve the same problem. But we want to use recursion and only recursion. So no looping, no built-in functions. So here's our first problem. Our first problem is 1 plus everything else. This everything, I will use an illustration in a second, but this everything problem kind of breaks down into 2 plus, where is it? This is not very clear. But this everything is the same thing as 2 plus everything. Does that make sense?
no. So you're saying 1 plus everything. So 1 plus 2 plus 3 plus 4. And then it's 2 plus 1 plus 3 plus 4 plus 5. And then 3 plus 1 plus 2. Is that what
So
you're
if I sum all these numbers 2 through 8, whatever that total is, I'm just going to say it's 40. I don't know what it is. Let's just say it's 40. So 40 plus 1. So another way of saying the sum of 2 through 8 is to say 2 plus 3 through 8. So that's going to give me the same answer, right?
Right.
I know it's very weird, but this is how recursion works.
Sorry.
So the first step is 1 plus all this stuff, and then all this stuff is the same as 2 plus all this stuff. And then we keep going. 2 plus all this stuff is the same as 2 plus 3 plus all this stuff, right? So everything in this case is the same.
If you, I wonder if it would be helpful to, when you're saying everything, just maybe if you say everything larger, that might help understand what it is you're, because I think
Okay.
that.
I have a little diagram, but it's built for a slightly different example, which I was hoping to get to, but yeah, okay, so so let's say, first off, let me make this just 4 numbers. So 1 plus 2 plus 3 plus 4 is 10, right? So how can I solve this problem by composing essentially the same subproblem over and over again? Well, I can do 1 plus, and now I will wrap this up in a nice parentheses. So the sum of all these is the same as the sum of 1 plus all of the rest, right? And the sum of all of the rest is the same as 2 plus 3 and 4. And I don't know directly what 3 and 4 is, or, you know, in this case, I could just add 3 and 4 together. And then this would tell me, so this is 7. And so now I can evaluate this one. So 7 plus 2, which means because I can evaluate this, and this is the same as this, I know that this is 9. And so I add 1 to 9. So I'm gonna do this example real quick, and then we'll do a slightly different variation of this, and it will be illustrated. So, okay, so let's see. Yeah, let's do it this way. So if the right. Anyway, so if the length of nums is equal to 0, there's again several ways we could do this, but I'll return 0. Otherwise, I will add up. So I'm going to call this subproblem. And then I'm going to return let me get rid of this. So let's just run it real quick. So what I'm doing here is here's my basic subproblem. The subproblem is I want to add 2 things together. But my bigger problem is that I have an array with a whole bunch more than 2 things in it. So I need to take the solution to this subproblem, which is I could put in my base case, but it's fine. And then I'm going to add that to whatever this returns. And this is going to return another, it's going to tack on another solution to a subproblem. And then just like the empty string, in this case, we're just adding a 0, so it won't change anything at the end.
So you said 9 is the base case, line 9?
No,
I'm sorry, what was the base case?
yeah, this is the base case right here.
Oh, okay.
All right, so I'm gonna give an illustration of a version of this. So this solution works and it's fine, but I want to show you another way of doing it, which looks more like a traditional kind of divide and conquer algorithm. So I have this array of numbers, right? And I'm just gonna show you this so we can illustrate. I don't want to go too much longer than an hour. So I'm gonna paste this here. All right, let's run this. So what we're doing here is our base case is going to return whatever the first two elements in the array, right? So in the first pass, this would be 1 and 2. Then in the recursive case, we're going to chop this problem in half. So every time we run through, we're going to chop the problem in half. So we're going to take the length of this array, and we're going to, so this actually works better. There's 8 here. I'm gonna chop this array in half. So the first half 1, 2, 3, 4. The second half 5, 6, 7, 8. Then I'm gonna return whatever addnums 1, 2, 3, 4 is, plus whatever addnums 5, 6, 7, 8 is. So this first function call, I don't have any, I don't know anything at this point. I just know that whatever this ends up returning is going to get added to whatever this ends up getting returned. But I don't know what these are yet. So I'm gonna have to keep going. So I kind of have like 2 separate tracks now that I'm following at the same time. I have one branch handling basically the first half of the array, and then the second branch handling the second half of the array. So let's get a little bit more visual here. So I have these 2 functions. Okay, this is going to be very poorly drawn, so I apologize in advance. If you're very picky about things being off center, I feel for you. All right, so I have my array that I'm starting with, and here's my recursive case. So I'm going to return whatever these 2 things added together are. So the first thing I'm going to do is I'm going to chop this in half, right? So the first half is going to go here. And the second half is going to go here. All right, so now I have whatever this returns plus whatever this returns, but I don't know what this is yet. So I'm gonna have to keep going. So I'm gonna have to put this here. And this over here. All right, so I'll take this and I'll take the first half and put this here. And I'll take the second half and put this here. So I have this first problem. And that's gonna lead me from here to here. And this other problem is gonna lead me from here to here, and then from here to here. And then this subproblem will actually hit my base case, right? Because if we look at the base case, you can see it's nums 0 plus nums 1. And if the length of the nums is 2. So, and that satisfies this. So this is now going to get replaced. So this is going to become whatever this is, 3. If I can manage to highlight all of this. So this just now becomes 3. I'm going to So now I've got 3 plus whatever the result of add numbers 3 and 4 is. And this, again, is the base case. So I'm going to return an actual value. In this case, it's going to be 7. So I'm going to very slowly and painfully delete this and replace it with something else. What? Okay, I don't know why that doesn't want to change font. All right, so now my base case has been hit, so I can actually evaluate these. And now I have evaluated this return value and this return value. And since I have both of them, I can now put these together. So this is going to equal 10, which means that that this equals 10, right? And now I know this, so I'm done here. I'm done with this branch. The problem is that I still have another branch to go, but the other branch looks exactly the same. So this will get divided into 2 subproblems. Those 2 problems will each hit the base case, which means they can be resolved. And so that will trickle back up to here. And then at the end, I will have an actual value 10 plus an actual value 25 or something. 6, yeah, whatever this is. And then I can actually add these together, and that will give me my final return value. Are there questions or comments?
Can we go back to that code real quick?
Sure.
Where exactly does it tell you to run the right half, the 5, 6, 7, 8? I'm not picking that up in the text because that looks exactly the. Oh no, you got the colon on the right side. Okay.
Yeah. So if we run this we can run this in the debugger. Yeah. We can see the call stack, this first call stack. Let me expand this. The nums is all of them, right?
Okay.
And then we're going to return, but it's a little tricky because it can't, in some ways it can't really return anything. So it's going to return whatever this is plus whatever this is. So it's going to try and figure out whatever this is first. So that's kind of where we are on this stack. So this stack is 1, 2, 3, 4, which is the first half, right? So that's what's happening here. And this is going to keep going, and it's going to get called again. So again, this is going to get split into subproblems yet again. So that this stack 1, 2, 3, 4 is going to get split ultimately into this stack, which is going to be 1, 2, and this stack, which is going to be 3, 4. So we keep going, and then we can actually hit our base case here. So we return. So this, we added 1 and 2, right? We added 1 and 2. So now we know what this is, but we still don't know what this is yet. So this gets put on the stack. So now if you look at this stack, we have 3, 4. We step through, this can hit our base case and get evaluated. So now this stack, the 1, 2, 3, 4, which is the first half of our original problem. I know this is very confusing, I'm sorry, but that's recursion for you. So this we now have enough to get an actual result for this first half.
So Chad, what if you only had 7 numbers? 1, 2.
Yeah, I'm kind of cheating. I'm making this easier on myself, so we don't have to do any other checks. So I'm trying to focus on the dividing and subproblem issue, not the
Okay.
other things. So yeah, this is slightly simplified.
Can you keep going just so I can see where it runs?
Sure.
5,
Yeah.
6, 7, 8.
So right. So at this point, we know what this is now, right? We know what this first one is. So now we need to start. It's like we've gone all the way down here. We've come back up and we know what this is. Now we have to switch over to here and just kind of start that process, work our way down again. So we go here and then 5, 6, 7, 8 again is going to get divided up into 2 separate subproblems. So if we look at this stack, we have 5, 6, and then this one will be 7, 8. So the 5, 6 stack is going to hit the base case. So that'll get evaluated. And we have to worry about the 7, 8, which is also going to hit the base case. And we can put all that together, 5, 6, which we have, 7, 8, which we have. So now we can return that value. Then we get everything. So 10 plus 26. So 10 over here, 26 over here. Again, if you don't already understand how this stuff works, I wouldn't expect this to be clear at this point.
Where exactly in the code does it know to run to start the second half of the problem 5, 6, 7, 8?
So it remembers. So the stack remembers where it is.
Where it left, where it
When
cut
it's
it
called.
off?
Yeah. So
Okay.
so once this returns, it knows I got to go back here. So it's going to keep evaluating.
Okay. I'll just copy that and run through the debugger and I'll sort it out.
I had the same question as Deborah. We don't need to get into how you would fix it, but if you did have an odd number or something that wasn't divisible by 2, it would break this particular, if you didn't
Yeah.
account for that.
Yes. Yeah. Because I'm assuming that we have 2, essentially an even number.
You could end up with a dangling thing or not hit your base case or something like that would happen.
Yeah. Yeah. So if so, that would just be, I mean, you just need to change a couple things, but I'm keeping it as simple as possible to illustrate the other aspects. Okay. So the challenges, smallest node is definitely more difficult. So you can consider that like, a more advanced one. So if you don't get to it, that's fine. binary search, I would definitely try to do. It's, you know, it's challenging, but I would definitely try doing it. And if you want to try doing it non-recursively as well, or first, depending on what you're doing. Again, I would strongly suggest doing it recursively, but if you're having issues and you want to do it non-recursively first and then recursively, that's also fine.
So, quick question, Chad.
Yes, yeah.
For the binary search, we can assume that the inputs are all, oh, okay, yeah, all the inputs are unique. So we don't have to worry about if there are two possible indexes for a number.
Yeah, yeah, and another thing which I mentioned, but I should mention again, is that in order for binary search to work, your array has to be sorted. If you have an unsorted array, binary search doesn't work because I can't. If it's just random numbers, I can't tell like, are all the numbers higher than me or lower than me, right? So they have to be sorted. Okay.